In this video, our essential question is, what are the properties of the three quadratic forms? Now it's possible, class, that we haven't talked about all of these forms yet. Maybe we just talked about standard form. But I'm going to put all these together on one page so that as we move through this semester, you can actually go back and reference this page if you want to take a look and see what are the different properties of these three quadratics. And what you're seeing here is that a quadratic equation can technically be written three different ways: in standard form, vertex form, and intercept form. So if you want to pause the video for a moment, go ahead and fill out all of these columns and rows, and then we'll begin to go through filling out this table. Okay, so you can see on this table that we've got 5 columns here. Based on the type of form the quadratic is in, how do we find the x value of the vertex? How do we find the y value? How do we find the axis of symmetry? How do we find the y-intercept? And how do we find the x-intercepts? So let's take a look at our first one here. Standard form quadratic is going to look like y equals a, and you can actually write f of x here as well if you want to put it in function form. Y equals a times x squared plus b times x plus c. And remember, class, just like our previous videos, that doesn't have to be x. That could be t or l or m, any kind of variable here for the value of x. That'll be our input. This a, b, and c value, those are going to be different depending on the actual equation or expression that we're looking at. But these a, b, and c values are going to help us to find at least some of this information. The first thing we know here is when we have a quadratic in standard form, the x value of the vertex is going to be found with this expression, negative b over 2a. So what you'd do here is you'd find the b value, switch the sign, put it on top, and then take 2 and multiply it times the a value. If you figure out what this fraction is equal to, that's going to be the x value of the vertex. All right, well, how do we find the y value? That's pretty easy. The function, we know how to deal with the function. If we know the x value of the vertex, all we do is plug it in to find the y value. So for here, we're going to say, we're going to plug in the x value and find y. And y is going to be our y value. Let's make that look a little bit more like a y. In fact, I'll put that in a different color so you see, and find y. All right, you hear helicopters buzzing around my house right now. That's all that is, so try to ignore that if you can. You probably are hearing it in the microphone right now. Okay, how do we find the axis of symmetry? We know the axis of symmetry is a vertical line that passes straight through the vertex. Well, the axis of symmetry is actually found the same way the x value of the vertex is found. You just find it with negative b over 2a. And remember, the axis of symmetry is going to be x equals some number. It's a line, and we'll be looking at that a little bit later. All right, how do you find the y-intercept? How do you find where this quadratic equation crosses the y-axis? Well, the cool part is it's always going to be the same as the value of c. So if c here were 10, the y-intercept would be 10. If there was no c value, if this equation had no value, no constant, then the y-intercept would be 0. Okay, and the last question is, how do you find the x-intercepts? Well, class, right now we're going to put a big question mark there. Not entirely sure how to do it. There is a way. We're going to be learning that later, but we're not going to cover that right now. All right, let's take a look at vertex form. We call it vertex form because you can find the vertex really easy with this form. Oh, back to standard form. Remember, class, we've covered this already. How do you put a quadratic in standard form? You put the squared term first, the term with an exponent of 1 second, and then the constant last. So here's vertex form. So the question is, how do you find the x value of the vertex? Well, that's just the value of h. Remember, when you take h out of a vertex form quadratic, you must flip the sign. And the reason why is because this minus sign is part of the equation. So if h is 5, it would show up in this equation as x minus 5. If h was negative 2, it would show up in this equation as x minus negative 2, which is actually x plus 2. So you see that the h value is always going to be the opposite sign from what you see in the actual equation. Okay, how do you find the y value? That's just as easy. It's the k. It's the value of k. Now in this situation, we actually keep the sign. And the reason that is because in the vertex form, this is a positive or a plus. That means if k is 2, this is going to say plus 2. If k is negative 2, this is going to say minus 2. So the sign in the equation is always the same as the sign of k. So you keep the sign. Okay, what's the axis of symmetry? The axis of symmetry is actually just the value of h. But we're going to write it as this. It's the x value of the vertex, which happens to be h. I could have just written h there, but I want you to see the axis of symmetry for standard form is the x value of the vertex. The axis of symmetry for the vertex form is the x value of the vertex. How do you find the y-intercept? All right, now this is a neat trick we can do. If you remember class on a graph, the y-intercept is always where x equals 0. Anywhere it touches the y-axis, the x value is 0. So all you do to find the y-intercept is you plug in, I'll write that a little bit neater. You plug in x equals 0 and find y. And I'll go ahead and make this a different color so you can see and find y. So we know the y-intercept is always at the point where x equals 0. So if you plug in as your input x equals 0 and solve for y, that's your y-intercept. How do we find the x-intercepts? Again, I'm going to put a question mark there. Not really sure how to do it at this point. Okay, last one, intercept form. We'll be covering that a little bit later on, probably in the next unit. Intercept form looks a little bit different than vertex and standard form. Intercept form, if you look at the name, it implies that we can find the x-intercepts really easy. Vertex form, you can find the vertex really easy. So intercept form, how do we find the x value of the vertex? It's just going to be the value of p plus the value of q divided by 2. I'll put this in parentheses so you see those are both on top. Okay, how do you find the vertex y value? Well, same way you actually do it for standard form. You plug in the x value and find y. And find y. Now, if you're thinking to yourself, oh gee, I got to remember these two methods for the standard and intercept form and this method for vertex form. Actually, you could have done the same thing for vertex form. If you plugged in the x value of the vertex, which is h, you would actually get the y value of the vertex. So it would have worked out either way. If you take the h value and plug it in right here for x, you'll actually get the y value of the vertex. So think about that, class. If you know the x value of something on a graph, you plug that into the equation, out comes the y value. You can always find the y value if you know the x value. Okay, how do we find the axis of symmetry? Well, same thing. It's just the x value of the vertex. And how do we find the x value of the vertex? P plus q divided by 2. So in this case, again, axis of symmetry, you always just take the x value of the vertex. That is your axis of symmetry. Of course, we have to write it as an equation, but we'll take a look at that later. All right, how do you find the y-intercept with intercept form? Okay, same way. plug in x equals 0 and find y. Again, we know the y-intercept is where x has to be equal to 0 when it crosses the y-axis. So plug in x equal to 0, solve or evaluate the function, and you'll get the y-intercept. Last thing is, what about the x-intercepts? Well, here's a good part. Intercept form does give us the x-intercepts. And that's just going to be the value of p and the value, I'll put and q. P and q tell us where this graph will cross the x-axis. But one important thing, notice just like in vertex form, there's a minus p here and a minus q here. That means to find the x-intercepts, we're going to have to flip the signs. Flip, didn't look like flip, looks like UP. Flip the signs for both of these, and we'll be covering how to do that later. So there's your basic table that tells you how to find these key pieces of information in your graph or on your graph when you have the three different forms of a quadratic equation.